Hello, welcome back to the broadcast. Things are going very well. I'm actually getting into crypto day trading, and so far I'm making money. So, as proof, let's check my Euro ledger. I started somewhere here. Last thing was a deposit, so I started with 366 euros. Then I bought things. This is all Luna 2. I bought, I sold. No, the beginning was Monero. I did some Monero experiments and I actually lost a little bit of money. So I went down to 364. I was kind of bummed about it. Small loss, but I was like, it's not supposed to be like that. So I switched to Luna 2, which is a much more volatile coin than Monero. So much more opportunity. I did stuff, and I ended up with 368. So I was up from where I started. And then I got the hang of it and traded some more Luna 2 and ended up at 383. So plus of 15 euros or something. And the last thing happened between me waking up. I was woken up by a phone call. It was 8 a.m. I slept a little more. At 8 a.m. I bought some Luna 2. At 12 something I sold it and I made this very nice profit. So it's really good for one day. Right now I bought some more Luna 2, and with that investment I am in the minus, but only very, very slightly. So I transferred 100 euros to a bank account in the meantime. So I went from 83 to... Oh, actually I'm on the up now. Yes. 84. Just in the last minutes, Luna actually recovered a little bit. So now I am plus minus 0 with the last stuff I hold, which is 40 Luna. If I wait a little longer, it will be sold automatically, at least part of it. I have a sell order in place, which is a limit order, meaning it's at a fixed price of 7 euro per Luna. It's 20 Lunas, so I'll get this automatically 140 euros. So it's half of what I'm holding. So yeah, it will be sold automatically, but only half of it. And yeah, whenever you have some crypto in your wallet, it still operates in the mind. Like, what happens if it crashes? That's like the only real danger. The only real danger is if the currency crashes, and it crashes so quickly that you can't even put stop loss in place, or you don't have a stop loss. You should always have a stop loss order in place usually. But even though Luna 1 crashed, Luna 2 doesn't look like it's crashing. In fact, it looks like it's alternating between multiple levels. And yeah, with stop loss there's not really any danger here. Yeah, and this is so volatile that you can make money in one day or in 4 hours. It's so cool. It almost feels too good to be true. Mature currency like Monero, of course, doesn't have this extreme volatility. This goes between 180 and 188 in one day, which is already 5%. But Luna 2 can do much more in one day. Yeah, this is like 30% in one day or more. Yeah, I also plan to automate this a little, or a lot. First, do some calculations about crypto in a program. I made a little collection of scripts here, something like this. This calculates the minimum price you need to sell at, depending on the price you bought the currency at. So I bought at 6.8. These are the fees, although they can be even a little bit lower. And calculating the fees, roughly we get this price. So if Luna 2 goes from 6.8 to 6.835, we are already happy because we can start selling at profit. And I have some more scripts like that. And the full crypto bot would actually screen recognize like this and actually operate Kraken. I don't know if they have rules against that. It's configured such that I don't need my 2FA for the actual crypto trade. So I can just by clicking in this window make the trades happen. So I could have my bot do this if I trust it enough. I mean, it's super easy to lose all your money here. Let's say you say sell Luna, you know, put some amount here, and you say limit price, and you just type the wrong price. Yeah, instead of 6.9, maybe you just say even something like this is annoying, but let's say in this case it doesn't really happen. But let's say the price actually was 60, and you put in 6. In this case, you would have to put in something like this. But let's say you sell this, and you know. This order is probably going to be fulfilled because it's a super good price. Somebody's going to be very happy, but you will lose basically all your investment. We could try this. I mean, what if I sell a really, really small amount? So one Lua, normally Luna. I used to program in Lua, so I say Lua sometimes. Luna. So the normal price is 6.93. Let's sell at limit, let's sell at 1, like really way too low. But of course we don't sell 1 Luna, we just sell, we can sell 100th of a Luna. Although that's not that interesting of a demonstration. So let's do this. So we receive 5 cents instead of 30 cents that we should actually get. And let's double check, triple check, quadruple check, and actually execute this. Okay, I have to sell 1. I don't want to sell 1 Luna at a ridiculous price, so I'm not going to do this demonstration right now. But it's probably very possible to just screw yourself doing the wrong trades. Yeah. Oh, we're nearing my target price. It is at 7 already, so this order here is going to be fulfilled in a second actually. I'm not even sure if I should go through with it because it seems to be still rising. Oh, it's already, oh, nice profit. I mean, maybe I could cancel this because... Oh shit, too late. It went through. Alright, I mean, but I made a profit, like, I made like 10 bucks on this. Maybe that's 7. So now we only have 20 left. Let's put in a new sell order. Or not. I mean, if you put in a really high value, then can't do much wrong here. So it's 7.02 and still rising. No, going down a little. This happens so fast. You saw it like a couple seconds. I had to think about it, and it was already too late. So we have 20 remaining, and we can sell it at 8 euros for sure. This will give me a profit of 20 euros. I will surely be happy with that if that price is going to be reached. Double check, triple check, 160 euros, yes. Boom, submit. Kraken is somewhat limited in the automated orders you can place. It doesn't even allow the basic stuff, which is to say sell if price goes low or if price goes high. This was what you would want for like the minimum automation. The minimum automation you need to safely keep your Luna and have the system react to both good events and bad events. Bad event being the currency crashes, good event being the currency goes above a reasonable price, so you make profit. So you want these two orders in place at once, stop loss and take profit. And they don't have this. It might be planned, I forgot. I asked them about it, but it's not there right now. I generally like the interface of Kraken actually. It's just that I need different windows open at once to do it reasonably. It's not in one window. I want this chart. I want the ledger, although no, ledger is just for checking stuff. What I need all the time is this, is my balance, which actually includes the crypto at their current prices. I need this. This gives me the actual market price and my open orders. Yeah, there's like one more view where you can actually see the trades you made. And it's also like split in two different like tables. On one ledger you don't see the fees, or you don't see what you converted to. On the other ledger you see the fees and what you converted, but you don't see the balance. This is actually, which one is this? Oh, this is pretty much the perfect table. It has the balance, the fee, what was being traded. That's pretty neat actually. Yeah, maybe there is one table that has everything I want. My old Luna, by the way, the crashed Luna, it's gone up a little again. I bought for, I think, €2. Now it's 59 cents. I will still keep this. Maybe by some miracle I will gain value again. Relatively unlikely, but who knows. Yeah, so once again, while making this video, I made some profit, which is really cool. Remember, I started with effectively 266 today. Wow, this is already like financing a pizza. Very good, big pizza. It may still happen that I make losses on some currencies in the future. I don't think I can rule that out. But right now it is going great. This is really, really, really fun. It's really good. Okay, so yeah, back to the toilet paper. Let me check. Okay, that was that. We can close it for now. Maybe close this whole thing, or yeah, I want some little ticker, little window on the screen somewhere. Also, I'm experimenting with the background, which is blue screen, or rather it's orange screen. Same thing, like blue screen, just in orange. So let me check my stuff here again. What we have 20 Luna, and we have limit order in place. It's good for now. I can close. I don't think Luna will crash while I make this video. I don't think stuff is that volatile. Okie dokie. This is the upcoming stock chart recognizer from screenshots. It's not completely done yet. Let me pick up where we were last time. Here, this one. A recognition network is calculating. Maybe I'll do a little bit here, or I will go to the toilet paper example. Okay, calculating. Yeah, this code is kind of slow. Scripting language needs a bit of improvement. So here we have 4 candidates for what might be this graph in the image. So one is up there, this line. This is the one, the actual stock graph. And we have one more. Actually, it was more down here. So more, which I'm confused right now. Let me see what the code does. How many regions do we actually display? Oh yeah, 4, okay. Oh, this is another region. Oh, it is a region, okay. Okay, this big region up there, the system says might be a graph. Obviously it's not. This one, it says might be a graph, and this one down here. And there should be a 4th one, or am I miscalculating here? No, in fact, no, it's only 3. It's only showing 3. So if we had a bit more logic to analyze these 3 objects, it would be very clear that that is not a stock graph, and down here it's not a stock graph. Just this one is. And also we could find it quicker. Right now the whole image is analyzed in all the regions in the image, which are many. In fact, they are almost 6,000. Each of them is checked as to whether it could be a stock graph. But we could do something like, if you have the input image, which is the one up here, if you just go vertically from top to bottom, just 1 pixel wide, just 1 line, and check all the regions you come in contact with. Then you will also come in contact with the actual stock graph. You just do a little local exploration here, to the left and to the right, to check out what kind of shape it is, and you will very quickly see this is a typical stock graph, while the other things, which are just horizontal, are definitely not stock graphs. So with some quick searching and some simple but effective heuristics, we should find things really quickly. I'm all for finding things quickly. In fact, ultra fast was one of the names I was considering as a company name or a product name. And we could definitely do an ultra fast recognition for this kind of object. And once you found the stock graph, you just follow it. Follow it to the left and to the right. And then you can interpret the results. Right. But I wanted to show you the toilet paper. Where did I put it? Oh, we need some better sorting here for sure. Track objects and webcam. Maybe it's in there. Gallery. Nope, that's just pictures of me. Here. Yeah, we need better search functions. We should have a list of all images in all Gazelle projects. For example, no, there's nothing here. Yeah, either I search all day or I write a little script. Hey, where is my toilet paper? I know I did that. I know I saved this image. Huh? Come on, give me my toilet paper image. I don't want to photograph toilet paper again. Or do I? Maybe I do. I am not finding this. I am not finding my toilet paper picture. So, stream has to be cancelled, not finding the image. Oh, it could actually be in the webcam project, of course. Yes, which is in a different base directory, which is why I didn't find it right now. Yeah, there we go. Toilet paper, close up. So it has structure, it has these, I'll call them dimples, of different sizes, small dimples, bigger dimples, and that's the same thing. It also has this flower motif going on. So, yeah, the question is, how can we analyze this image? And we kind of did a similar thing with this project. Oh, which is missing all its images. Let me grab this from the server. The images are on the server actually. Focused scenes, there's it. No, actually I don't need that directory. Where are my data sets? Here. Okay. Focused scene text training. And let us copy. Oh, it's there. So the problem is, the the link. It has /root instead of my user. So we could actually just fix these images, right? Make a little script for this. Yep. Fix image references in gallery. Okay. It shouldn't be that hard. We have a class called gallery image, which has a path. And while we're at it, let's improve this class. We have a new base class called concept for trained listeners, which allows us to set variables, to set fields in the object and automatically trigger this change event, which saves it to the database. So it just saves like one line of code there. Makes things more reliable. Cannot reduce. Stuff of stuff. Why is this class in this? Why, what? Methods but. Oh yeah. Oh, there's some old stuff in there that's getting compiled too. Yeah, whatever. We just have to fix it quickly. Thank you, Duck. Oh, yes, it's actually, it's finding my repository. That's pretty neat. Yeah. Yeah, this one should be linked. It's not, but interesting. Nice to know that search engines know my stuff. Okay, quick fix here. Was it the only one? I don't know. I think it was more than one. Occurrence. Make responder is another one. Once, not cubic, public. And I think that's all. Okay, now we have this improved class, and it's time to restart Gazelle. Let me just go through the images and fix the path. We could actually, we could try to extract from the travel log of the project how the path should change, but well, no. We just put the new path in manually. Loading, loading, loading. I need more cores. When my crypto profits ramp up, I'll get a new computer. Okay, we have the gallery, blah blah blah. Go home. Go Scratchpad. Do we have some convenience function? I don't think so. Can use general database list function to get all the images. That's good. And let's check out the image path. Yes, that's the wrong path. Do we have a JavaX function for changing the base of a path? File path. Changing the base directory, basically. Let's say file base. Base file name? No, that's not the one. I have something like in subdirectory, relative path. Yes. Name relative to physical subdirectory. But in fact, maybe we just want to use strings. I mean, we're looking to take the root off here and put home Stefan there. So yeah, I mean, it's drop prefix or null / root. Path. And we convert to a string. Yeah, there it is. Relative path. And new path then is user directory plus relative path. Yes, exactly, that's it. And if I actually do it, then image set path, new path. Do it false. And let's print something or return something. Change path to path. There's no result here, we continue. Okay, that is good. Let's say do it true. We get changed path blah to blah. We do this again. We get no results because they have all been changed. And now if we click in the gallery is notoriously bad at updating itself. But actually I thought we might see the image now. It's the wrong, it's the right directory, right? Yeah. Yeah, the gallery is really bad at updating itself. But wait. Now I'm confused. Let's reopen the project. Oh, I checked out the wrong ones. I had to check out these number images. Okay, these are the demo images, or the examples to recognize from an actual data set that somebody made. And my goal is also to recognize all of these. And what I did in the process is this threshold thing. Just have a brightness threshold to make every pixel either black or white. And now here we can select an actually existing image. Very nice. So that works again. It had broken when I moved it from the server to my machine. And here's somewhere here there's our selector for the brightness threshold. It is here actually. So let's clean this up a little here. Give this some more space. And yeah, you can see Pocket Flash is nicely readable. If I change this value here, it will become unreadable or partially readable. So there's a whole range in the middle where it perfectly works. This one is not good in the corner here. So this one is actually roundabout perfect. From there we could easily do a recognition. You see the letters are fused together here, which if you have a, let's say, dumb or very mathematically strict recognizer or segmenter, it would store these two, or actually the third one too. It would store these three letters as one to be recognized. We as humans see that as three letters, but the basic segmenter, which just takes contingent blobs of color, will merge these three together. But that's easily fixed. I mean, we should definitely have a way to be able to handle that. So this same threshold thing I want to do with my lovely toilet paper. Let's check out how we did this, because it was a little complicated. You should also have a way to put this code in a different window, such that I don't have to resize this here all the time. It's a bit complicated because it stores this value in the blueprint itself, the blueprint of this element, and the instance, which is the value that's used in the actual calculation. Yeah, we have blueprint and instance. That's always the thing with these networks. Because you have to have these both. Blueprint is what you design as like a piece of code, basically, in a visual way. And instance is what is being used for one particular image during the recognition. And if you deliver your recognition code, you might not even have the blueprints completely. You will have the script too. Yeah, okay, that's not really the point. But the point is you need to have these instances separate from the blueprint. Say you have 100 recognitions in parallel on one machine. You don't want to have 100 copies of this whole network thing. So this seems to me it's a standard thing. Brightness threshold slider. That's a nice and complete name. We don't have a real library of network elements yet, but we can just copy this code. In fact, this is already automated. I did that in the last stream. This configuration thing. Almost in the type here. Get property value. Yeah, I think if I deliver something by default, if I calculate something every time, I can get rid of this whole configuration thing. I think that should work. Yeah, it still works. So if I enter and exit again, exit and enter again, exit, enter, it keeps the value, everything good. Okay, perfect. Try again. Yes. It looks good. Okay, so here's our brightness threshold slider. And did we make a toilet paper project yet? No. Recognize toilet paper. It's definitely a life achievement. Toilet paper recognition program. And it makes for a good YouTube title. For sure. Recognize toilet paper. So we start with a gallery image. Copying the code. Image. It seems to not be bootstrapping itself properly. Yeah, I mean, simple fix. If not null. Our gallery is empty because the images are in the other project. Right. Toilet paper. Copy image. Gallery. Paint. Paste image. Yes. New image. Second example. Copy. Paste. There we go. There's our image. Okay. It's so beautiful, isn't it? This must be the best time of my life. Recognizing toilet paper. That's what I studied for. Recognizing toilet paper. So here's our threshold thing. We could put the name also in the code, so when I run the code, I could set this name. That's pretty decent because it allows us to only copy the code and have details like this name already like also set. Actually, it should be really easy. It's in the blueprint object. Network element. Let's put this blueprint name in here, also called blueprint. It simply has a name, doesn't it? Or a description or something. Identifier. Yep. I used to call it identifier. Now I call it name. Who cares? Blueprint identifier. Okay, that didn't really work, I think. What if we put it in here? It will trigger a change event. That's what this one does. Change the network, and it should show actually. Yeah, okay, if we put it in here, it's fine. Let's say we make a function called default name. If there's no name, it will use the provided name. Default name, name, if empty identifier, set identifier to name, return yourself for convenience. Bam. Cool. So, but the slider doesn't do much good unless we connect it to something. Oh. Bracket. Forgotten. Tail of the forgotten bracket. And scale. Image down. We don't need that right now, I think. Although we could do it. We definitely need this one. I'm tempted to check the Luna price. Yeah, the junkie, the crypto junkie talking. Need my fix. There's hundreds of thousands of Lunas being traded within the 24-hour range. So like the 40 Luna that I trade is like, it's but a drop in the bucket. So I'm not influencing the market significantly by buying and selling. Once you sell a lot or buy a lot, you will actually change the price by buying or selling. And I have not really completely figured out how that would actually work. Like if lots of people do this opportunistic trading that I do, just buy cheap, sell high, does it stabilize the price, or does it more like make it unstable? I'm guessing a lot of people do this, but yeah, I don't know. Anyway, I'm not really influencing the market. I'm just caring about my own profit with these small trades. Okay, back to the thing here. Here's my slider. Machine is a bit slow. New node. print default name 2-bit image. Configure. Name has been set. And we just do some connection. The user interface is still a bit of a pain. Only a little bit. This one goes down here. Now we can actually see our ports. And this one is not configured. Yes, no, wait. Where's the port? This one should have a green port. Okay, I needed to auto-create the port. Yeah, okay. Okay, we have connections, we have an image, that's good. Yeah, so I'm hoping these dimples can be made very clear by using the right threshold here. Let's see if that assumption is correct. Yeah, it kind of is. I mean, you need like multiple thresholds for the whole image, which is a bit of a complication. But, you know, here, for example. So these are like little blob-like things. They are circle-like, roughly, more or less, ellipse-like, and they are similar in size, but the size is getting smaller if you move in one direction, and they are on a line, which is like a curve. They are on one curve, and the distances are fairly similar. So these are all the criteria. This kind of tells us that this is something special. The same criteria would not be true here. You have more like grids of blobs, but it's also recognizable. But you don't have like one line of blobs like this. Basically, whenever, you know, we can play with all our sliders and pre-processing things. Whenever something seems unusually structured, we take note. So this here is unusually structured. It's things that are on a line or on a curve, slightly bent curve. And they all have the same shape, which is also a simple shape, etc. So this is a thing to take note. If you take this whole region, the big thing on the left, it's one messy blob. There's nothing really special about it, or it's no simple geometric shape. That would not be notable. Here this is notable, and if we keep moving the slider, we get slightly different regions, but they are all in the same place. So if we only take the center of each of these regions, the center will be basically the same. So we say, okay, that's the same object again. There's nothing structurally changed between these settings here. If I move it a little. And also they maybe confirm each other. Anyway, this is something that could be recognized. And that would give us our toilet paper indicator. If you play a special sound when it's detected. I actually moved the webcam around on the table. Like I used to have this robot, the Anki vector robot, which would produce images like this one. It just rides around on the table. If it gets close to a thing, it would see something like this. I had to sell the Anki vector at some point, or I sold it. Not had to, but it was getting a little repetitive. Anki vector has its own programs. It's like a little Tamagotchi. It wants attention. Constantly does something. It's getting a little old. I did manage to program it, kind of, actually, with some effort. Now the Anki vector is super expensive. I got it for 100 euros. I sold it for 100 and something, 125, I think. Now you get it used for, I think, 300. They apparently stopped producing it or something. I didn't check the details, but it's like super expensive now. Yeah, if you want to trade something, trade robots. Apparently, robots are rising in value. Oh, Kraken on Firefox is not so perfect. Dude, what the heck is this? I'm sorry, what is this? I have a standard browser. Please show website. And why is it giving me Terra Classic first? That's the crashed coin. Yeah, fantastic, dude. I want to do that too, actually. Hello. Hello. Prices. I hope my browser will pass this test. Oh, the subcode is actually fixed. Actually, no subcodes really. Just recognize the toilet paper. Oh yeah, my machine is overloaded. Luna 2. These websites have super complicated JavaScript, I think. Maybe it's uploaded. It's quite a real possibility. Yeah, here's our volatile coin. It's so young. Yeah. Low 372, high 12 euros. So my preferred view is probably this one. Yeah. Okay, nothing major happened while I was doing other stuff. If anything, it lost. This is the price where I would buy it again. I made profit by selling like here. And I need 3.5 cents of a difference here to make profit with my fees. So 6.65. If I buy now, was it that low? Yeah, it was, I think. If I buy now and it goes from 6.65 to 6.7, I already make profit. Is that for real? It sounds so magical. Let's try again quickly. Do the computation. Yeah, fees and actual fees might be even lower. If we put in 6.65 as current price and run, we get 6.685 as our minimum, as our break-even point. And see, we just surpassed it. So if I had bought Luna at 6.65 and literally a minute later or up to 5 minutes later I sold it, I'd make a profit. I have made a profit, would have made shit, English, man, it's so complicated. If I had bought and sold, I would have made profit. That is the correct grammar, I think. It's like really easy to make profit here. Unless, you know, go into a slump and you have to lay low for a while. I'm tempted to do this stuff again, man. Let's keep the window open and hope it doesn't slow down the machine. Ah, I can keep it in the background, right? Sure, why not? I have enough screen space. Open window, this one is okay for now. So, can we put everything? Well, let's do like this. It's turning into a live trading show. I'm so hooked, man. I made like 20 bucks today. Just by clicking in the right spot at the right time. Alright, so go find Dimples. I think Dimples is the proper name. I'm sure in the industry they call these dimples too. I'm absolutely certain, in fact. No, I'm not. Okay, so standard thing. Next standard thing is do the regions. Regions. New node. max pixels per region. Let's ignore that. Let's put the name thing here. Default name regions. Configure regions, fine. We have our little port. We connect the port. We should have regions. I mean, this is a stupid kind of visualization. Maybe you could actually visualize this better right here. One way would be to give each region a color, like a random color. This looks funny when you have new input all the time, but it's a static image, so no new input. And I've done this before. I've done this before in the screen cam. Actually, it's not linked anymore, I think. But I did have it, and it was called. Forgot what it was called. Hope I can find it. Region random color. If I don't find it, it's easy to replicate. Yeah. Yeah, not actually finding it. But we can go to the other project here and see what we did here. I call it mask here, where the promising regions are bright and everything else is black. So we can just do a similar thing with all the regions here. Visualize regions. Let's quickly see if we're on the right track. Yes, we can show the number, for example, but I wanted to show the colored regions. So we have the regions. If empty, let's say we say no regions. Here we make the empty image, which is black by default. Then we go through our regions. Here we want a colored image of some kind. Go through the pixels, paint the region, and make an image surface. Color is random color. And we probably need to convert to an integer, and then we are done. And oops, random color. It has a toInt method, right? ToString, to. It doesn't have toInt, are you kidding me? As int, get int. Okay, I'll take it. Set int, okay, fine, that's correct. Okay. Oh, it's still loading. I think this browser is slowing everything down. Even when idle, these JavaScripts that they have, they just eat CPU. Encoding overloaded, yeah. OBS is complaining also. There's not much to do, I think, except buying a new computer. Which hopefully I can do soon. So here, regions. Get our random color. Get int. And yeah, I think. What's the holdup? Oh, okay. Was still calculating. Yeah, that's exactly how I wanted it. Beautiful. Beautiful. That's our colored image. Actually, I love it. Let's make a screenshot. So here we see that these little blobs all have their own color. That's perfect. It's kind of artistic even. First time you see toilet paper in color, isn't it? So these blobs are what we're looking for. So what's the definition of a circle-ish region? Because mind you, it's not an exact circle, neither is it an exact ellipse. But it's something like a rotated ellipse, some little blob. How do we measure this mathematically? I can think of different ways. One might be to actually just measure the length of the outline in relation to the number of pixels, for example. Because a round thing has a very low number, the lowest one basically. The circle has the lowest number of pixels in its outline compared to any other shape. So that actually could be pretty decent way. Yeah, why don't we go with that? Did similar things in this project where we gave each region a score. We actually did this, no, we did this here in the tech graph. Exactly. I made a whole class for it, which is maybe not the worst approach. We can also output a nice text and everything. Yeah, that's a good idea. Yeah, copy the whole thing. New node. Circumference. Is that the right word here? And we could say it's circumference in area, staying within mathematical terms. right. Oh, we always have to say this. It's a weakness of my language. I shall fix that. If I refer to a field in the object, I always have to say this something, this other thing, which is obviously kind of idiotic. Okay, analyze regions for each region. This is a simple one. We take region. Pixel count is a direct method call. Sort regions by circumference divided by area. Number of pixels, that's the whole thing. Make this object first. Area, region, number of pixels. Circumference is we need another object to give us this outline. Outline region. Which one was the right object? Yes, just this function. T22 region outline. You could actually put that in the region object also. Outline, which is a path object. And oh, see, Luna 2 is falling. It's a good time to buy it. Tell you right now. I mean, it's very close to the 24-hour low, or even the absolute low actually. Let's check the longer time. It's less than a week old, so okay. No, the lowest low was, where was it actually? Must have been for a super short moment because it's not even showing here. Stop freezing. Okay, that must have been the point. Really shortly after being issued. I mean, the coin was super young there. So in recent times, like one day, is like really close to the low point here. Hey, let's buy some Luna. I want to make some money live on stream. I'll use my favorite browser though. Not this one here. It's gonna be super slow. Everything is overloaded. Am I still logged in? Why am I still logged in? Who knows? So this is still open. Buy Luna. Let's buy some Luna. Let's get broke or not. 657. Going up again. 658, 657. Let's just buy it. Ruining myself live on stream. No, I can't ruin myself with this. No problem. There we go. Bought some Luna. My goal is to go to the 300 mark today sometime actually. Up from 266 to 300. We lost a little again, but it's because Luna is so volatile. 281. Very nice. Okay, we can close this here, I guess. It's exciting. $648C, it's even lower, so I can now punch myself and say, oh my god, bought at the wrong time, oh my god, I'm so stupid. But I don't think that's a good approach, actually. Huh? That used to look better. What's happening? Okay, good. So how do I get the length of this path? Does it have a length, or should it have a length object? Length method. Yes, it does. You can say size, you can say length, and you can say end steps. Choose whatever name you like. And now we calculate our score. Score, which is double, is, or even this kind of double. Double with capital D is a nullable. Without capital D is not nullable, so always has to return some number. We can return not a number though, which is different. Null is different from not a number. It's obvious, right? Computer logic. This yeah, my score, I said my score is better when the area is big compared to the circumference. And what we could do is convert the score to a probability, meaning something between 0 and 1. Yeah, let's make a nicer string here. Star format, circ area. Or actually we can just use join with space. Circ. Area. Score. Score. Yes. Sort later. Let's keep the code around. Yeah, okay, nice score. Yeah, why not sort it right now? Of course, there's an error because we didn't do various things. For example, to make some ports. Is it connect? There we go. Right, I am, okay, it's the first time I make a method in my language returning a primitive value, which actually it's not set up for. I could fix that quickly, but right now I just do the quick thing. Read and outline was not found, I just called the wrong thing. I forgot the parameter. That looks better, it's calculating. We have some very big regions. I think we have these like these huge regions also as our first results. Wait, what? I think I'm... wait. That's kind of funny. Let's visualize the results. We could actually just visualize the region in here. Just show its outline, like its shape in the list here. I think that's a super nice idea. Map sorted. Have our analyzed region. This is the same thing as before, but if we make a pair, we can show the region and outline as an image. A region to image, something exists. Region to black white image. In fact, it should be a 2-bit image, which is smaller. Yeah, that should be clearer. Region 2, black white. What if I want the size? I mean, I can resize afterwards. There's also this shortcut function. Okay, let's use this one, that's fine. Oh, the region to image converter actually has a problem. Maybe the region is actually faulty, like it reports the wrong bounds. Because otherwise this should not happen. Or is the bug here? Width, height. I do not see... wait, what? No, it's... what, wait. What? Show me the error again. It's directly in the run method. Where is the error? I have width and height. I make a byte array with width times height. I goes to H, X goes to W. Oh, I see what... oh my god. How did this ever work? Or it didn't actually. Maybe I changed it recently and didn't test it, which is embarrassing. I'm incrementing I twice, which is of course ridiculous. Ridiculous. Ah, yeah. I have to recompile the whole thing. Okay, when that is fixed, we can see the region here. Let's just resize this image. Scale. Buffered image to max width or height. Let's say 10. and wait for the recompilation. Luna not rising yet. Wait, when did we buy? We bought for 660 something, I think. Maybe we bought at 666. That would be so funny, because it's such a mature joke. 666 joke. Let's check the ledger. When did we buy on this super overloaded machine? I'm so looking forward to my 16 core. Where's my 16 core? Who sponsors my 16 core? They're not that expensive anymore. Where is my ledger? This is one of the ledgers, definitely. Oh man, it is slow. Spot market is too fast for this kind of slowness. It can't work like that. Hello. Okay. Hello. Ledger does not give me the price. But if I go to, say, trades and wait a gazillion time units, I will see the price we bought it. Come on, ThinkPad. Okay, price was 658. Okay, so right now we cannot make profit. I just want to remember that, 658. So at 6, if we sell at 670, for example, we're good. At 670 or above, we will make profit. And we'll have made Kraken richer, because Kraken collects fees every time. Okay, run again. Error. Okay, scale buffered image, not completely right. I think we can just say true buffered image first, and we're good. What do you mean null? What is what null? What? How can the result of this be null? That's ludicrous. Sort something and I'm okay. It was still okay. If when it visualizes, it doesn't have an indication of being in process. Okay, very nice. See, now we have these really small regions here. I think the region shows in white instead of black, which I think I don't like. I want to show it in. No, it should show in white. Yes, yeah. I wanted to see the region in black actually. Background color is normally 0. Actually, I can just change this, I think. No, I have to recompile everything. We can make a new utility method. Okay, we have to fill the background. If background color is not 0, fill array pixels background color. Oh, we have to recompile it anyway. Hallelujah. Fair enough. Byte arrays can only be filled with bytes. Can't argue with that. So use the inverted version. Background color is 255 and foreground color is 0. And use this new function as soon as it's compiled. I'm wondering, what about the scale? What about the size of this thing? If you scale something up, like factor 2, does the outline get twice as long? Actually, it depends on the object, I think. It depends on how fractal it is. It's actually called the fractal dimension of the outline. If you have something like coastline and you zoom into it, you will see detail you didn't see before. If you zoom into a circle, you will not see new detail. So the scaling of the outline is different with these two objects relative to how much you zoom in. So I think something like that we probably should take into account, because the first region we get is this big one, which is definitely not the one we want, and it's not very circular. Maybe we just get this big region first because it is big. We divide by the area, so actually I don't think that's the problem, but we could check that. Okay, it's calculating. It's calculating, is it? No, it's not calculating. It's alerting me to an error. Yeah, it should show up there. Show it like a code error, I guess. Oh, lunar rising. Still waiting for some more profit to be made. Let's lower the calculation delay. Every node element has a 1 second or up to 1 second calculation delay. I was putting this in to see how the things are calculated, but right now we don't need that anymore, pretty sure. Let's just go down here with like 0.1. Okay, here's our regions. And even though it's small, you can see many of them are actually pretty blob-like. These must be the regions we wanted to see. Some of them are not really blob-like. These are not really big. Like these are not the ones. So, I mean, one criterion we didn't check out is like how many curves the outline has. That would be another way of defining. Yeah, of course, that's a good way. If it's just like one smooth curve all around, that's a dimple-like shape. But even though our first filtering is imperfect, we could just look for the correlations, like are multiple similarly sized regions in one straight curve. Straightish curve. Curves are not straight. In one curve. See, now it calculates faster. We're not stopping this at any point, so we get all the regions listed. That's why this down here takes so long, I think. We can round the score for printing, I guess. Score. Ah, no, down here is what I wanted. Here. ToString score, we just round to an integer. Yeah, this should say visualizing while it is visualizing. I should put that in. Score 9, score 7. These are all still pretty nice blobs though, if you ask me. The first two are not really nice blobs. So the minimum we would look for is three of the dimples in a row. I mean, basically we want more of them. Here, if we have a better threshold, here, that's a good one. Here we have 1, 2, 3, 4, 5 in a row, or even 1, 2, 3, 5. 1, 2, 3, 5. 1, 2, 3, 4, 5, 6. Here, if we take this bend here into account, we have like 6 of them. I mean, definitely we have 3 basically in a straight line, and that I think is a very big hint. And very unusual. And they have roughly the same size, like it's not like one is ridiculously bigger than the others, although they do change in size. Let's show the position also. Center, this region, bounds, center. Yeah, let's say visualizing. Not here. visualize node, and we temporarily set the flag, visualizing. Make a Boolean variable, visualizing, and show the state here, visualizing, at etc. What the heck is that? Did someone delete my font? What is this? Let's make a screenshot. This is so weird. Where did my letters go? What is happening? Everything freezes right now. Oh my god. I'm not out of memory at all. This machine has lots of memory. Okay, whatever that was. Whoa. Wowzers. Default true. And this one we don't have to recompile. Oh my god, everything is so slow. This machine is on its knees. Maybe the Java process is calculating too much, but it doesn't even seem like it. No, OBS is just super busy. Oh man. Find regions. Find 3 regions in a straight line. Positioned in a straight line. Oh, visualizing, very nice. Good. Calculating, visualizing, that's perfect. Yeah, so the naive way is to take all subsets of the regions of size 3 and check them for this property. That's slow, but it's not kill everything slow. Like 170, so it's roughly 172 cubed, which is still too much basically. So long term we would need some optimization. And let's just look for the things in the neighborhood of one region. Basically, if you start with any of these regions that you're interested in, there in the neighborhood there's actually just these other regions. The neighborhood is very clean here. But you need a data structure that supports this kind of lookup by position. It's all doable, just maybe not right now. Why do we have 170 regions? Because we also have these little tiny dots and stuff. We could also just pre-group them by size and get much faster that way. And that's actually a pretty good idea. Well, oh, they have bad score anyway, these small regions. Oh yeah, of course we can pre-filter by our criterion here. I mean, yeah, score 4, score 2. Scoring is not bad, but it may miss some of these. But these are actually not results we want. These are not dimples. They're not round enough. I think all the dimples are pretty much in the beginning here. So, oh yeah, that's the way we can do it. We go through this list and we do all the combinations of 3 regions, but we start with combinations of regions high up in the list. And only if those are not successful, or if we have more time, we take combinations that include regions from down, way further down in the list. So actually, I'm wondering if I have a function for that sort of thing. We're also combining 3 of those. Basically, I give a number, like the number is 3, and I want a sum of 3 natural numbers that give me I want 3 natural numbers, the sum of which is 3. In which case there's only one combination, which is 1, 1, 1. But we don't even combine regions with themselves. So, I mean, it's a little involved, the whole thing. If I give it a number like 6, then there are more combinations. You could have 3, 1, 2, or you could have 3, 2, 1, or 4, 1, 2. And for that kind of thing, I have a function. It's called spreads. Spreading things into buckets, it's a similar thing. Why is it still visualizing? What? Oh, I know why. It doesn't update the GUI. This has notifies, right? No, it doesn't. We need boulevard with notify. Okay, so we make this a boulevard with notify, and we update our flag automatically, and we can just remove this and everybody's happy. I'm still thinking about this optimization thing. How I avoid pairing 170 regions with 2 other regions out of the same pool. How to avoid this cubic combinatorial explosion in a general way that will also help us for future problems. I think this one we can actually close for now. Making the startup a little faster. So we have 172 regions. So the power of 3, that is 5 million. I mean, it's not the end of the world. In fact. Yeah, what does being on a straight line mean? We can use the angle function. We have an angle function that gives us the angle between 3 points. 3-point angle, exactly. Yes. P1 center and P2. So if this angle is roughly 180 degrees, they are on a straight line. Yeah, I mean, that's a mathematical thing that we can do, actually. So let's go ahead and do it. Regions on straight. Find regions on a straightish line. I have something like for iterator, which is nice in this instance. So we iterate first, second and third. until we have 3 regions to check out. Oh, we don't return anything here, I think that's a problem. Oh, we don't connect. Didn't connect. This one needs an output port. And we connect. Now we have stuff. Okay. Why do I not see the actual values? Iterator. I used this before somewhere. Let's find it. For iterator. No? What? I did use, I'm sure I used this. Is it on the server? Maybe. First iteration works. Let's check the test cases. For iterator. Okay, they're in a special function for iterator. Oh, nested. We have nested. Ah. Oh, okay. Okay, so it's for nested. Okay, that doesn't work, but this works. Okay, I see what's happening. It's called for nested. There, and I think now we get, yes, we get our first combinations of regions. And okay, we get let's put the center also in the analyzed region class. Def center point. Center, B center, C center. Error. pair? What do you mean pair? Oh, we are returning pairs here. That's actually not what I wanted. I just wanted to put that in the visualization. Dev visualize this. Visualize Java objects. Wait, maybe that's already happening. I think this is automatically done. Is it? Let's improve that. Call visualize function. Component visualized. Yes, no, it's not. Okay. Okay. There was a little problem. Okay, this is still the same thing, but now you get regions in here cleanly, and we are showing the centers of the regions. Here. Okay, we have the 3 center points. We take our 3-point angle. Yeah, first we check if they're all the same. Then we say no, that's not what we wanted. P1, P2, P3. If equal P1. Yeah, if equal P1, P2, or equal P2, P3, do nothing. We can say continue, I think. Now we take our angle. And let's just return the angle. Okay, interesting. The angle is probably in radians. Yes, it is in radians. So what we're looking for is an angle of pi, or yeah. Let's see an example. Angle 0. No, this is going back on itself. That's not the thing we want. It's definitely, the function does mod with 2 pi, so the result is between 0 and 2 pi. So I'm guessing we're looking at difference from pi, right? Angle 2. Not angel. Angle. Here's one with exactly pi. It's almost too good to be true. No, that's the bad result. Of course. We want the lower results. Okay, getting closer. Yeah, so we sort by this angle. Pair. How can we make an object that's like a pair but sorts itself automatically? In fact, if we just put the score first in the pair, if you sort the pairs, you will get the lower scores first. That's super elegant. Never even thought of that. So we take the angle and then our 3 points, or even the full regions. Let's just take the points for now. And yeah, my idea was we just let it calculate and show all the results. Wait, let's see. What if we just take a few of these? That gives the error. Why? Oh, okay. Yeah. Let's say out of these first 10,000, we take the best ones. List. Creative name. Sorted list. But we want the lower score first, because low means low distance to pi, which means it's a straightish line. My hope is that out of these 10,000 we get a few of the cripples we actually look for, and then we just throw them in the image like with a line. And then I'm actually super hungry, even though I only streamed for 2 hours. Didn't eat much of anything today. Oh, where's my crypto portfolio? Oh, it's actually going down. We're in the loss right now. New lows. But it's all fine. If Luna 2 crashes this early in its history, I'll have to swallow the loss. Where is our error? Oh yeah, it's trying to compare the second thing also. Okay. So my clever trick with the pairs doesn't really work. But I have other functions. Pairs sorted. There is something. Pairs sorted. Pairs sorted. Descending. Oh, that doesn't even exist. Okay. Let's create it then. And we make another visualizer similar to this one here. Oh. The reboot happening. I'm getting a little nervous with this falling price here. It has to go up, back up, right? How crappy is Do Kwon's new coin is the question. New node. Param. Let's see. Possible lines. A list of some stuff. Did I copy the wrong code? No, I didn't. We just need to find the size of the original image. We extract this from our data somewhere. So we go to the first one, we go to the B, we go to the A, and the image. Like this, I think. It's a very nested expression. Do we need color? Maybe we don't. And we do some stuff. No, we need an image we can paint on using standard Java methods. Let's see if that works anyway. Create input ports. We need to connect this, which doesn't have an output port yet, to this here, there, no regions. Okay. I think this one needs a recalculation. Yes. Get black image, that's to be expected. And I want the white image instead. Okay. And now we show some stuff. We have a pair with a score and a triple. and we simply draw a line on the image. Let's say we take the first 50 results. A is our analyzed region. We get the center of that. And we do that 3 times. So we draw a line from P1 to, with, let's say, color black. And we draw another line from P2 to P3 with any random color. And we are curious what we'll see. Oh, interesting. Interesting. It's pretty, but it's completely not right, I guess. What is our score here? Oh, we are sorting in the wrong way, aren't we? Yes. Lower score means better. So we are showing the worst ones. No wonder it doesn't make any sense. Let's make a screenshot anyway. I just like how this looks. This artifact. Okay, Luna's going up a little. What was our target? 666. Uh-huh. So these are very, very good scores, but are they actually good hits? No, I don't think they are. Let's filter the regions first according to our original list that was filtered by dimple likeness, circle likeness, circlishness, analyzed regions. This will already make everything faster, etc. Calculate. And what's happening here? Oh, okay. Much different picture. What is it telling us though? If anything. These do not really look like straight lines to me. Oh, I'm showing way too many of them. Okay. Number to show. Let's say I show 10. I think it's not passing this parameter. Variable scoping is not good in Java. My scripting language. Variable scoping needs to be improved. Okay. This does not look anything like what I wanted. It's supposed to show lines between these regions here. Let's show more analysis. Let's make an actual class, analyzed triple. We have 3 of these regions. We have the angle. We have the distances between the 3. Yeah, the distance should also be similar. That's another thing, of course. Distance 1 and distance 2. Okay. New analyzed triple. ABC. So now we have this nice object instead of just a generic triple. Okay, yes. And we need to calculate these distances. The distance 1 is point distance P1, P2. And distance 2 is distance from P2 to P3. And let's show this in some way. Okay, because these distances are varying wildly. Like distance 1 after 3 points, 1, 2, 3, then D1 is the distance, first distance, and D2 is the second distance, and they should be kind of similar. Otherwise we are unhappy. So we make a combined score. Distance score. So it's 1, distance 2, and we want something like a score for score for our ratio. I don't think I have done this yet. Distance to probability. Ratio to probability. So if the ratio is less than 1, no, we could use it directly. We take 1 over the ratio. Is it simple like this? 1 is highest and the other ratio is lower. I think this could basically work. What if one of them is negative? Negative. We assert they're not negative. No negative values allowed. Yes. Okay. I think that's reasonable. Ratio to probability. Distance 1, distance 2. And we have to say this every time. Add function. Well, the full list is only 7,200. I'm only taking the 20 best dimples, doing all combinations of them, and we get a result list of 7,000. Even less than the 10,000 that was set as a limit. So now we can score all of these again by not only the angle between the three things, but also this distance thing. Yeah, I'm running on empty, definitely. Need a break soon. But this is so nice. I want to see our dimple triples found. At least like one of them, like find one of these triples here. Radian 2 degrees, yes, and we round the thing, give us a nice little printout. This is still like random garbage, but we'll figure it out. Okay, they all have angle 0, which is good. Let's check out the distance score. D score. Yeah, some of these have bad distance score because the distance varies wildly, and some others have better distance score. Yes. So we sort again. Score is the distance. Let's say we make a score function. Score. We just add the distance score and the angle score. Distance to probability. And now we have to sort descending. So this one has low angle, which is great. And the distances are very close to each other. This is actually a very good candidate. So I think some of these we should already... Oh yeah. We should make these lines thicker, step 1. Set stroke. Make thicker lines. I think it's called basic stroke. Let's say 3. Yes. And the red and the black I can't really distinguish, so I want red and green. Oh! Oh wow, we have some good results, I think. Like these are definitely on one line. Wow, man, yes, good. What if we show more of them? Show 100. Okay, that gets messy. Yeah, how about we do different coloring? We do the same color for both parts. And color is random color, but we make it a little darker. So we're sure it's not white. Yeah, there's a darker function provided to us by Java. Okay. Wow, we're finding them. We are finding them. Of course, if there are 4 in a row, you will also find different combinations. Or if there are 5 in a row, you find like a triple with 2 skipped blobs. Yeah. Getting somewhere though. Luna is low. Low, low, low. Oh, very low. Is it time to get out? Swallow the loss? I hope not. Okay, see, we have this here. But, I mean, where is it in the original picture? Yeah, it's in the right spot, actually. We can overlay the original picture. We can make connections here. We have this image there, which has an output, and we can simply connect that to this node also. Original image. And we should have 2 input ports now. Yes, there's our second one. I have to bring it close here to connect. Yes, no, why does it not connect? Oh, wrong one actually. Wait, what did I do? Is it disconnected? Oh, maybe it is. To connect this one again and connect that one. There's no simpler way to do connections right now. I know it's a little unintuitive. So we take the original image and just overlay it, underlay it, underlay it. Draw image. Draw image on image. What? Is it the same problem again? With the parameters not being passed through? That's really nasty. That's a stupid problem that should not exist. That's really a bad problem. Ew. Yeah, no, that's nasty in fact. But we can get around this by being tricky. Yeah. Oh yeah. Alrighty. All right. Yeah, it has found a few of them. Like here. Definitely. Yeah, I mean, the thing is, intuitively I was thinking, okay, these regions are close together, it will find those, but it doesn't matter, it doesn't check what's close to anything else. It just goes, it could take regions that are far away from each other. Can we take that into account somehow? I mean, sure, we can make the distance, the absolute distance, another factor. The point is more like if something is in between these or not. We can also check out the sizes actually, and we can check out the color. Not connect black to white, which I think we may be doing. White things are also a region. Yeah, it's correct. I mean, we're getting close here. It's pretty cool actually. Okay, what if I show 100? These are not bad results. What is this thing? Oh, this is the center region. So the one, we should filter that one out also. Either by color or by size. So we have maybe the areas should be like similar. Yeah. Area score. Area score. We have the area in here, I think. Let's take the 3 areas. Yeah, ratio to probability. A area, B area. And the same thing for B and C. And we take the average of these. And that should be our score. Fraction average. Exactly. So we have a score of the distances, a score about the angle, and we have an area score. Combined score. Oh Luna, how low have you fallen? It's kind of cool how it fills this network with data. Step by step. Oh, this B, yeah, that's annoying. Having to write this, I should really fix that part of the language. This A area, that's B area, and another bracket. Plus doesn't take 3 arguments. I think we can use double sum. Yes. All right. Is this the latest result? Yeah, I guess. I mean, it's getting better, no? These are all pretty good results, actually. What are our 10 best results? These are good results, look here. Yeah. So regarding the toilet paper detection, we could say if these triples, if a significant number of these kind of triples are found with a good score, it is toilet paper, recognized by its dimples. This one is of course pretty garbagey, because the slider is wrong. If we fix the slider value, that can't be the result. That's not recalculated. I think something is not recalculating here actually. Or wait, what? I mean, this result has nothing to do with the input, does it? It's still the same thing as last time. No? Oh look, this one is not updating. Yeah, there's some problem with the auto update here. Okay, that's the new result, that's better. Calculating here, calculating there. And yes. Okay, look here. Look here. Yeah, I mean, that's pretty neat. We could still do the thing where we don't connect white to black. That's pretty neat, actually. Wow. Yeah. But it has pretty much found our toilet paper dimples. So one more color score. A region brightness 1, brightness 2, brightness 3, and our score is actually, we could use the standard variation. Standard variation? Digital variation. average. Is it called deviation? Deviation, yes, not variation. Standard deviation, right. Standard deviation, yes, there we are. Which takes a double array, yes, exactly. Let's do this here. Standard deviation. B1, B2, B3. And then we just convert to a probability. And it's another entry in our score sum. This color score. Pretty cool, right? Right. Did it change something? I mean, it's still connecting white to white, which is okay. Black to black. What if I show all the entries? Okay. Okay, that's gonna be a mess. That's like bad. We can cut off by score. Double average. Let's use the average instead of the sum. So our scores are all between 0 and 1. And min score, whatever, 0.5. If score is less than min score, continue. Okay, so 0.5 seems to be, oh no, wait. We want to show the whole thing. Okay. 0.8. Yeah, these are good results. These are more or less a straight line. The angle is pretty bad. I think the angle should make more of an impact. And that's what we need, like a learning function for, like a perceptron. I call it perceptron. It's not technically a perceptron, but something that figures out that the angle is more important than the other things. So here, where we have the average of our scores, of all 4 components of the score, we take the angle as being more important than the other things. So we find the best stuff. What if we take only the dark ones for a test? For